FIMAR. Commitment to quality and service. We are a company dedicated to the manufacturing of fishing and aquaculture nets. An important and necessary interaction between raw material, production process, and a high-quality control system is our responsibility. The selection and control of these elements to finally obtain high-quality products is our commitment. Production process. The production process of the outlined products will be explained below. Monofilaments. Knotted twisted twine netting. Knotted braided netting. Knotless Rochelle netting. And twisted ropes. Monofilaments. Continuing the process of modernization and expansion of our company, FIMAR has implemented a new extrusion area which is in charge of manufacturing polyethylene, polypropylene, and polysteel monofilaments. Monofilaments manufacturing involves loading small pieces of raw material into a hopper at one end of the extruder. The raw stock is fed from the hopper into the extruder, essentially a heated cylinder, where it is softened. Once the material is liquefied, it is forced through a die, and after emerging from the die becomes continuous monofilaments, which are successively heated and stretched to reach the required strength and finish. Knowledge of all their monofilaments' characteristics is crucial in determining an adequate mechanical and thermal process that standardizes both the production process and the end products, essential for outlining their distribution. The most important things to obtain high-quality products in this process are tenacity, denier, and elasticity, among others. Strength, elasticity, shrink-resistant, and UV-resistant qualities are tested and verified in our laboratory. General and specialized applications requiring a monofilament are diverse, both for the manufacture of ropes and cords, as well as for weaving fishing nets and aquaculture. Knotted twisted twine netting. FIMAR fulfills the technology and most sophisticated machinery to attain a perfect spiral arrangement of the yarn through a dual twisting process. Yarn production is arranged in the warp coils and reels to feed the loom frames, forming successive and symmetrical knots, which in turn will shape the mesh. Knotted braided netting. The knotted braided twine net is commonly called knotted braided net or simply braided net. Its manufacturing process is similar to the knotted twisted net. However, this one is made from braided twine obtained by braiding 16 strands of yarn. Knotless Rochelle netting. To manufacture knotless Rochelle net, the yarn is put onto reels by means of the warping process. FIMAR verifies the quality of this process using a warp stop, which is an infrared ray that stops the process when there is any defect in the yarn, however small this may be. This allows us to maintain constantly the quality of our products. These reels are then mounted onto the loom, and all the variables needed to make the net are programmed in the main computer, such as the mesh size, weaving density, and weaving revolutions, among other aspects. FIMAR's looms have cutting-edge German technology. Additionally, EBC technology controls the supply of yarn to the loom. whereby an optimum twine tension is guaranteed to the whole length and breadth of the netting. This technology automatically regulates the supply of yarn to the needles, considering the exact amount of this in relation to the speed of the loom. This synchronization is handled by the computer system of each loom, which also manages other variables such as speed and density of yarns, thus achieving a high-quality, fully balanced net. These nets are subject to the following processes. Review by means of screens. Any possible defect would be detected in order to correct it. Boiling, dyeing, and resining of the nets by means of immersion and circulation of fluids in high-temperature autoclaves to rid them of impurities and dye them. Net drying by means of heating. Heat setting of the nets, consisting of simultaneously applying heat and tension to reorder the fiber molecules and assure the net dimensions and quadrature, and at the same time preventing subsequent strong shrinkage. Second, screen review to confirm there are no defects. And finally, packing of the finished nets for local sale or export. Twisted ropes. Twisted ropes are the result of making successive twists to one or more raw materials. Production starts by joining strands, in which the first twist is given to obtain S-shaped strands. These strands are then separated into groups of 3, and a second Z-shaped twist, contrary to the previous shape, is given to them. In that way, the strands release the energy retained and the necessary balance is attained. Lastly, the reels obtained with the strand from the second twisting are arranged onto the laying machine. The number of turns per meter, the speed, and other variables have to be programmed in the control unit, and 2 further S and Z twists are applied in a single simultaneous process, thus achieving the desired diameter in a fully balanced rope. This is attained by using top-quality materials and high-precision machinery with sensors and computer units that control the accuracy of the several variables of the process for each meter of rope. The correct rope performance is critical for sea operations, as they directly take the hydrodynamic forces exerted. That is why FIMAR produces ropes with specific characteristics for each particular job, like the salmon cages anchoring, mooring floats, the main line of seine nets, and many other applications. Quality control system. Quality management throughout the company is given the third element in this interaction. FIMAR's quality control system is as follows. Automatic machine controls having sensors that feed information to computers which regulate the operation. In-process control, which determines the accuracy of the thicknesses of the yarn and the nominal twine number, mesh size, and inside mesh selected, and mesh quadrature, among other factors. Post-process control, which entails a rigorous quality test of 100% of production by means of screens equipped with electric rotors, and laboratory tests of samples taken at random from both raw materials and products in various stages of the process to check that their specifications meet the requirements and pre-established standards of quality. FIMAR, therefore, meets its quality and service commitment by providing the highest quality assurance standards on products and service that exceeds all customers' expectations. FIMAR, commitment to quality and service.